In the deepest silences of human history, we have always looked up, our gaze drawn to the celestial fire. For millennia, that impenetrable veil of night held its secrets close, offering only pinpricks of light against an eternal, unfathomable darkness. We told stories to fill the void, crafting myths of gods and monsters from the patterns we saw. The cosmos was a canvas for our imagination, but its true nature remained a mystery locked away by distance and time. The universe we knew was confined to the limits of our own eyes. Then, a few centuries ago, we built extensions of our sight. Glass and metal, ground with patience and precision, became our new windows onto the heavens. With each new observatory, each larger mirror, the darkness receded. We discovered worlds orbiting our sun, and then countless suns composing a vast galactic island. We learned that our own Milky Way was but one of hundreds of billions, each a swirling metropolis of stars, scattered across an expanding void. One telescope, in particular, became an icon of this quest. Launched into the silent vacuum above our obscuring atmosphere, the Hubble Space Telescope became humanity's most powerful eye. For 3 decades, it delivered dispatches from the cosmos that were as beautiful as they were revolutionary. Hubble showed us stellar nurseries, the birthplaces of stars, and the ghostly remnants of their demise. It captured galaxies colliding in a slow gravitational dance, and it peered so far back in time it could see galaxies as they were, when the universe was just a fraction of its current age. Yet even Hubble had its limits. There was a boundary it could not cross, a curtain it could not pierce. The very earliest epochs of the universe remained hidden from its view. The light from the first stars and infant galaxies, having travelled for over 13 billion years to reach us, has been stretched by the expansion of space-time itself. Originally born as brilliant blue and ultraviolet light, it has been redshifted so profoundly that it now arrives as faint, invisible infrared radiation, a form of light perceived as heat. To Hubble's optical sensors, this ancient light was entirely invisible. The cosmic dawn, the moment the first stars ignited and ended the cosmic dark ages, remained in shadow, a story untold. To read this missing first chapter of creation, humanity would need to build a new kind of eye, an instrument of unprecedented scale and sensitivity, designed not to see as we do, but to perceive the faint, ancient heat of the universe's formative moments. It would have to be the largest, most complex, and most powerful space observatory ever conceived, a generational leap in technology. This dream, born while Hubble was still in its infancy, would take more than 2 decades of ingenuity, heartbreak, and perseverance to realize. It was a technological undertaking so audacious, so fraught with peril, that its success was never guaranteed. It would be named the James Webb Space Telescope. Its primary mirror is a work of art, a breathtaking mosaic of golden hexagons. Nearly 3 times the width of Hubble's, this colossal collector of light was too vast to fit inside any existing rocket. So, engineers devised a solution of remarkable elegance: origami. The mirror was constructed in 3 segments that would fold up for launch and unfurl with microscopic precision once in the cold of space. Each of the 18 segments is fashioned from beryllium, a metal both incredibly strong and exceptionally lightweight. They were polished so perfectly that if one were scaled to the size of a continent, its largest imperfection would be mere inches high. Then, each mirror was coated with a microscopic layer of pure gold. This is not for aesthetics. Gold is a near-perfect reflector of infrared light, the very messenger Webb was built to capture. This golden honeycomb would act as a vast bucket, catching the faintest, most ancient photons of light, particles that have been traveling, uninterrupted, since the dawn of time. To detect such ethereal signals, the telescope itself must be phenomenally cold. Any heat from the observatory would overwhelm the ancient light it seeks, like trying to hear a whisper in the middle of a rock concert. Webb needed to operate at a staggering 230 degrees below 0 Celsius, just a few dozen degrees above absolute zero, the point where all atomic motion ceases. To achieve this impossible cold, The telescope required a shield, a guardian against the light and heat of our own Sun, Earth, and Moon. The solution was a magnificent, 5-layered sunshield the size of a professional tennis court. Each layer is made of a specialized material called kapton, thinner than a human hair but incredibly durable. Coated with aluminum and silicon, these layers are separated by a vacuum, creating an insulating gap that is spectacularly efficient. As the sun's energy penetrates the first layer, most is reflected back into space. The residual heat that passes through is then radiated out into the void between the layers, with each successive sheet becoming colder than the last. The difference in temperature between the sun-facing side and the shaded, instrument side is almost beyond comprehension. One side is hot enough to boil water, while the other is cold enough to freeze nitrogen solid. This colossal, delicate structure also had to be folded, compressed like a parachute into the rocket's fairing. Its deployment in space was perhaps the single most complex and riskiest sequence of maneuvers ever attempted for a robotic mission. It involved 140 release mechanisms, 70 hinge assemblies, 8 deployment motors, 400 pulleys, and nearly 1/4 mile of cabling, all of which had to work in perfect sequence. Hundreds of single points of failure meant that one snag, one faulty pin, could have rendered the entire multi-billion-dollar observatory a piece of space junk. For weeks, the world watched with bated breath as it slowly, gracefully, and flawlessly unfurled in the silent vacuum of space. After its launch on Christmas Day, 2021, Webb embarked on a month-long, million-mile journey. Its destination was not an orbit around the Earth, like Hubble, but a unique gravitational oasis in space. This location, known as the second Lagrange point, or L2, is a place where the gravitational pulls of the Sun and the Earth balance perfectly. It allows the telescope to orbit the Sun in lockstep with our planet, permanently keeping the Sun, Earth, and Moon behind its sunshield. Here, in this region of deep cold and shadow, the telescope cooled, its mirrors aligned with nanometer precision, and its sensitive instruments were brought to life. For 6 months, humanity waited as the observatory was commissioned, its systems tested, its vision sharpened. Then, in the summer of 2022, the wait was over. The James Webb Space Telescope opened its golden eye and returned its first dispatches from the unseen universe. The first images were more than just data. They were a profound revelation. They were shared with a world hungry for wonder, a testament to what we can achieve when we dare to pursue the seemingly impossible. The first object of its gaze was a familiar celestial landmark, a region of intense starbirth called the Carina Nebula. Hubble had photographed this stellar nursery before, producing an iconic image of gas towers and cosmic dust. But where Hubble saw a beautiful yet opaque cosmic landscape, Webb saw something entirely different. Its infrared vision pierced through the obscuring veils of gas and dust, like a spotlight cutting through fog. What it unveiled was a scene of breathtaking detail and activity. The image, dubbed the Cosmic Cliffs, revealed a celestial shoreline where torrents of ultraviolet radiation and powerful stellar winds from colossal, young, blue stars are carving away at the nebula's wall. This turbulent boundary, a battleground between creation and destruction, glowed with an unprecedented clarity. But the most profound revelation was hidden within the nebula's dark clouds. For the first time, we saw hundreds of previously invisible, newborn stars, their faint red light, finally able to escape their dusty cocoons. We were witnessing the very first moments of stellar life, seeing protostars still gathering mass from their natal clouds. Webb's instruments could even analyze the chemical composition of the dust and gas, revealing the raw ingredients from which stars and, ultimately, planets are formed. It was not merely a photograph. It was a census of a stellar city in the making. Next, the telescope turned its attention to a compact cluster of galaxies, known as Stephan's Quintet. This formation of 5 galaxies, 4 of which are locked in a cosmic ballet, has been a subject of fascination for astronomers for over a century. Again, Hubble had captured this grouping, showing the graceful, distorted tendrils of stars being pulled from the galaxies by immense gravitational forces. But Webb's view transformed our understanding of this intricate dance. Its infrared sensors revealed vast shockwaves larger than our own galaxy, where one of the galaxies is crashing through the cluster at millions of miles per hour. It showed immense tails of gas and torrents of star formation ignited by these collisions. Even more remarkably, Webb was able to perform a detailed forensic analysis. Using its powerful spectrographs, which spread light out into its constituent colors, like a prism, scientists could read the chemical and physical story of the quintet. They could measure the temperature, density, and composition of the material flowing between the galaxies. And at the heart of the topmost galaxy, Webb unveiled a monster. It pierced the dust shrouding the galactic core to reveal the brilliant glare of material swirling into a supermassive black hole, 24 million times the mass of our Sunday. The observatory's instruments measured the outflow of energy from this active galactic nucleus, showing us in exquisite detail how such cosmic engines regulate the growth of their host galaxies. We were no longer just observing the dance, we were dissecting its every move. The observatory then cast its gaze upon a dying star. The Southern Ring Nebula is a planetary nebula, the beautiful, expanding shroud of gas expelled by a star in its final throes. For tens of thousands of years, the dying star has puffed its outer layers into space, creating a magnificent, intricate bubble. Webb took two separate portraits of this celestial ghost. The first, in near-infrared light, showed the nebula's structure with crystalline clarity. The second, using the mid-infrared instrument, or MIRI, delivered the most shocking revelation. For the very first time, it clearly showed that this was not one dying star, but two. At the very center of the nebula, locked in a tight orbit, was a pair of stars. The dimmer, dying white dwarf and its brighter companion. It was this binary companion, stirring and shaping the outflows of its dying partner, that created the nebula's complex filigreed structure. A long-suspected theory was confirmed in a single, stunning image. We were looking at the future of our own sun, but a future complicated and sculpted by the presence of a hidden partner, a story of a shared death written across the heavens. Perhaps the most scientifically transformative of the initial releases was not a spectacular image, but a simple line on a graph. It was a spectrum, a chemical fingerprint from the atmosphere of a distant world. The target was WASP 96b, a so-called hot Jupiter, a gas giant planet orbiting a sun-like star over 1,000 light-years away. As this exoplanet passed in front of its star, a tiny fraction of the starlight filtered through its atmosphere before continuing its journey to Webb's mirror. The telescope's instruments captured this light and analyzed it with unprecedented precision. The resulting spectrum was a revelation. The dips and wiggles in the graph were the unmistakable chemical signatures of water vapor in the atmosphere of another world. Webb not only detected water, but it also found evidence for clouds and haze. It provided the most detailed atmospheric composition of an exoplanet ever recorded. This was a watershed moment for science. The ability to analyze the atmospheres of distant worlds is the key to one of the most profound questions ever asked. Are we alone? While WASP 96b is not a habitable world, this demonstration was a proof of concept. It confirmed that Webb has the power to detect the chemical ingredients for life, gases like oxygen, methane, and carbon dioxide in the atmospheres of smaller, rocky, Earth-like planets orbiting other stars. The search for biosignatures, for signs of biology on a galactic scale, had officially moved from the realm of theory into that of observable science. Webb had opened a new frontier in the quest to find life beyond Earth. Finally, there was the main event, the image that encapsulated the very mission of the telescope. It was Webb's first deep field, a look into the abyss of space and time. The target was a galaxy cluster known as SMACS 0723. Following the precedent set by Hubble's legendary deep fields, Webb stared at a minuscule, seemingly empty patch of the southern sky, a patch of sky so small it is equivalent to the size of a single grain of sand, held out at arm's length. For just 12.5 hours, the telescope gathered the faint, ancient light trickling in from this tiny window. The result was, and is, one of the most significant images in the history of science. The picture that emerged was a treasure chest of galaxies, a glittering, chaotic field of thousands of stellar islands. Some were spirals like our own, others were fuzzy ellipticals. They appeared in a kaleidoscope of colours and shapes, but what made the image truly mind-bending was a phenomenon predicted by Albert Einstein. The immense mass of the galaxy cluster in the foreground, some 4.6 billion light-years away, was acting as a cosmic magnifying glass. Its powerful gravity was bending and warping the fabric of space-time itself. The light from far more distant galaxies, located deep behind the cluster, was being distorted, stretched, and magnified, appearing as dramatic, elongated arcs of light. The 21st. This effect, known as gravitational lensing, allowed Webb to see objects that would otherwise be far too faint and distant to detect. In those smeared, lensed arcs were some of the most distant galaxies ever seen. We were looking at light that had travelled for more than 13 billion years. We were seeing these galaxies not as they are today, but as they were when the universe was a mere infant, less than 1 billion years old. Their light carried the fossilized record of the universe's first cosmic structures, beginning to coalesce out of the primordial darkness. And Webb achieved this staggering feat in less than a day. It had taken Hubble weeks of exposure time to produce its deepest images, which were still not as sharp or as deep as this first glimpse from Webb. This single portrait was a resounding declaration that a new era of cosmology had begun. We now possessed the power to witness the assembly of the first galaxies, to push our observational horizon back to the very edge of the cosmic dawn. These first images were more than just pretty pictures. They were a paradigm shift, a fundamental recalibration of our place in the cosmos. They represented the culmination of decades of human curiosity, collaboration, and relentless innovation, involving thousands of scientists and engineers from across the globe. They were a gift to humanity, a shared moment of wonder that transcended borders and reminded us of the power of looking beyond ourselves. Each pixel contained a story, each wavelength a clue to our own origins. In the billowing clouds of the Carina Nebula, we see the same processes that must have formed our own sun and solar system 4.6 billion years ago. The dust and gas swirling in those cosmic cliffs contain the heavy elements, the carbon, oxygen, and iron forged in the hearts of previous generations of stars. These are the very same elements that constitute our planet, our bodies, and our blood. In the atmospheric data from WASP 96b, we see the beginning of a new scientific journey, one that may one day answer whether the conditions for life are common or exceptionally rare. For the first time, we have a tool capable of methodically searching for habitable worlds and scrutinizing them for the chemical imbalances that could signal a living biosphere. This shifts the question of extraterrestrial life from a philosophical debate to a tangible, scientific research program. The coming years will see Webb turn its gaze toward promising targets like the small rocky planets of the TRAPPIST-1 system, worlds that may hold the potential for liquid water on their surfaces. What we find there could reshape our understanding of biology itself, and in the faint, red smudges of the deep field, we find the oldest part of our own cosmic family tree. These are our galactic ancestors, the first pioneering structures to ignite with starlight and begin seeding the universe with the building blocks of complexity. Webb's ultimate quest is to push even further back, past these early galaxies, to find the theorized first generation of stars, the so-called Population 3 stars. These pristine giants, forged only from the hydrogen and helium of the Big Bang, are predicted to be hundreds of times more massive than our Sunday. They would have lived fast and died young, exploding in cataclysmic supernovae. that performed the first alchemy of the cosmos, creating the first heavy elements. Finding these first stars would be like finding the mythological titans of the universe. It would be the final, crucial link in our chain of cosmic origins. The release of these first images marked the end of the telescope's commissioning and the beginning of its long scientific mission. They were a demonstration of its capabilities, an overture for the grand symphony to come. Now, astronomers from around the world are using Webb every single day, pointing its golden eye towards their own chosen mysteries. They are mapping the weather on planets within our own solar system, like Jupiter and Mars, with a clarity never before possible. They are studying the formation of new planetary systems around nearby stars, watching as worlds coalesce from spinning disks of dust and gas. They are hunting for the universe's most elusive objects, from the origins of supermassive black holes to the nature of dark matter and dark energy. The telescope is not just an upgrade from Hubble, it is a fundamentally different kind of observatory. Together, they will work in concert, a multi-wavelength powerhouse. Hubble will continue to provide its stunning views in visible and ultraviolet light, while Webb reveals the hidden universe of the infrared. It is like adding a new, superhuman sense to our perception of the cosmos. It is the difference between seeing a forest in the bright light of day and then suddenly being able to see in the dark, observing all the nocturnal activity that was previously hidden from view. The universe has become a much richer, more dynamic, and more complex place. We stand at a unique moment in the human story. The darkness that once defined our understanding of the night sky has been pushed back to the very edge of creation. The silence is being filled with data, with whispers of water on distant worlds, and the faint, residual glow of the universe's first light. The James Webb Space Telescope is more than an instrument of science. It is a vessel for our collective curiosity, a time machine built of beryllium and gold, and a testament to our unyielding desire to understand where we came from and to know what else might be out there. Its journey is just beginning. The discoveries of the next decade will undoubtedly rewrite our textbooks, reshape our cosmic perspective, and present us with new mysteries we cannot yet even imagine. For now, we can only look at these first postcards from the edge of time with a sense of profound awe, humbled by the immense beauty and complexity of the universe. This magnificent observatory has finally allowed us to see. The great, dark expanse is a little less dark now, and its greatest secrets are finally, tantalizingly, within our reach. Picture this. You're a physicist working late in your laboratory. You're running calculations that should be routine, predictable, safe. The equations on your whiteboard describe reality itself. They are the fundamental rules that govern everything from the smallest particles to the largest galaxies. These are the laws you've spent decades mastering. They are the mathematical truths that have guided human understanding for over a century. But then something goes wrong. The numbers don't add up. The results contradict themselves. Your most basic assumptions about the nature of existence begin to crumble before your eyes. You double-check your work, triple-check it, and bring in colleagues to verify what you're seeing. But the conclusion remains the same. Reality itself appears to be broken. Physicists are discovering quantum paradoxes so profound and so fundamentally disturbing that they're questioning everything. They are questioning everything we thought we knew about the universe. These aren't just abstract mathematical curiosities. These are experimental results that suggest our entire conception of reality might be nothing more than a comforting illusion. Today we're going to explore the quantum paradox that's keeping scientists awake at night. The discovery that's forcing them to abandon cherished beliefs about the nature of existence itself. What you're about to learn will challenge everything you think you know about reality consciousness and the very fabric of space and time. Now prepare yourselves. We begin. For nearly a century, physicists have been wrestling with what they call the measurement problem. It sounds technical, almost boring, but don't let the name fool you. This is the crisis that threatens to unravel our entire understanding of the universe. Here's what makes it so disturbing. In quantum mechanics, particles don't exist in definite states until they're observed. Before a measurement is made, they exist in what scientists call a superposition. They occupy all possible states simultaneously. An electron can spin both clockwise and counterclockwise at the same time. A photon can travel through multiple paths simultaneously. A particle can literally be in several places at once. This isn't just a theory. We've proven it experimentally thousands of times. The math works perfectly. Our quantum technologies all depend on these bizarre quantum properties. These technologies range from the lasers in your Blu-ray player to the microchips in your computer to the magnets in an MRI machine. But here's where things get terrifying. When we actually measure these quantum systems, when our instruments interact with them, something impossible happens. All those multiple simultaneous ghostly states instantly collapse into just one definite classical outcome. The electron suddenly spins only clockwise. The photon picks a single path. The particle materializes in one specific location. It's as if reality itself is forced to make a choice the moment we look at it. The problem is nobody can explain why this happens. The mathematical equations that describe quantum mechanics with breathtaking precision, like the Schrödinger equation, don't include any mechanism for this collapse. According to the math, particles should remain in superposition forever. They should evolve smoothly through a landscape of possibilities. But they don't. And that discrepancy, that gaping conceptual hole at the very heart of our most successful theory of nature, has created a crisis. It is a crisis that scientists are only now beginning to confront publicly. Think about what this means. We have a scientific theory that can predict the behavior of quantum systems with an incredible, unparalleled precision. We can calculate probabilities, design technologies, and manipulate matter at the atomic level, but we have absolutely no idea what is actually happening when we make a measurement. Our most fundamental tool for understanding reality contains a mystery so profound that it calls into question whether an objective reality even exists. An objective reality existing independently of our observations. Some physicists, including pioneers like Eugene Wigner and John von Neumann, have proposed that consciousness itself plays a fundamental role. They propose it plays a fundamental role in quantum mechanics, that the act of a conscious observation is what somehow forces reality to choose a definite state. This is the moment a mind becomes aware of the outcome. But this suggestion is even more terrifying than the original problem. If consciousness determines reality, then what we think of as the objective physical universe might be nothing more than a projection of our own minds. Other scientists, in an attempt to avoid giving a special role to consciousness, suggest that all possible outcomes of a quantum measurement actually occur simultaneously, but they occur in separate parallel universes. This is the many worlds interpretation. Every quantum measurement, every coin flip at the subatomic level creates a branching point, a point where reality splits into multiple non-communicating versions. In this interpretation, there are infinite copies of you experiencing every possible outcome of every quantum event. Right now, in countless parallel universes, different versions of you are living completely different lives. These lives are based on the outcomes of quantum coin flips that happened years or even seconds ago. But even this mind-bending interpretation doesn't solve the fundamental problem. It just pushes the mystery deeper. Why do we experience only one branch of this reality? What determines which version of the multiverse we find ourselves in? The questions multiply faster than the answers. The terror isn't just philosophical. recent experiments have made the measurement problem concrete, measurable, and utterly undeniable. A team of scientists at Griffith University in Australia have developed a paradox. This paradox is backed by a rigorous mathematical proof. It forces physicists to abandon one of three fundamental assumptions about reality. Their work demonstrates mathematically that these three basic beliefs about the universe cannot all be true simultaneously. First, there is the assumption that when we measure something, the result represents a single real event in the world. This seems painfully obvious, but quantum mechanics, with its superpositions, suggests it might be false. Second, there is the assumption that we as scientists can freely choose what experiments to perform. This allows for a genuine, unbiased, scientific investigation. This is the bedrock of the entire scientific method. And third, there is the assumption that information cannot travel faster than light. This is a cornerstone of Einstein's theory of relativity and our understanding of causality. Each of these assumptions appears completely reasonable. Most scientists consider them to be obviously true, the very foundation of a rational worldview. But the Griffith team has proven with mathematical certainty that if quantum mechanics applies to the observers themselves, then at least one of these cherished assumptions must be wrong. They've even performed experimental tests using entangled photons that confirm their theoretical predictions. This isn't just an abstract thought experiment. They have used entangled photons to demonstrate that the paradox is real, measurable, and logically undeniable. The implications are staggering and deeply unsettling. Either our measurements of the world do not reflect single real events, or we do not have the free will to choose our own experiments, or faster-than-light influences exist and are constantly propagating throughout the universe. Pick your poison, because reality requires you to abandon one of these fundamental tenets. The horror deepens when we consider what this means for the nature of scientific knowledge itself. Science as a process depends on the assumption that we can perform controlled experiments, and it depends on trusting the results to tell us something objective about the world. But if the very act of observation fundamentally changes what we are trying to measure, then the entire scientific method might be built on a foundation of quicksand. And if different observers can legitimately mathematically disagree about the outcomes of identical experiments, this brings us to one of the most disturbing developments in modern physics. The Wigner's friend paradox, originally conceived as a thought experiment in the 1960s, has now been experimentally verified. The setup involves nested observations. One scientist, let's call her Alice, makes a measurement on a quantum particle inside a sealed laboratory. At the same time, another scientist, Bob, stands outside the laboratory. He treats the entire lab, including Alice and her measuring device, as a single large quantum system. The results are deeply philosophically unsettling. The scientist inside the lab, Alice, opens her box and observes a definite outcome. Let's say she sees the particle spinning clockwise. She records this as a fact, but the scientist outside, Bob, who treats the entire lab as a quantum system, can, according to the same rules of quantum mechanics, mathematically demonstrate something. He can demonstrate that the particle, the measuring device, and even Alice herself remain in a state of superposition. Alice is simultaneously seeing the particle spinning both clockwise and counterclockwise. Both scientists are using the same established, experimentally verified quantum mechanical rules, but they reach diametrically opposed, contradictory conclusions about the same single physical event. Recent experiments at the University of Vienna have confirmed that this isn't just a theoretical problem. Real observers can genuinely disagree about the fundamental facts regarding the same quantum system. The experiment proves that there is no single objective outcome that is true for all observers. Reality itself appears to be observer-dependent. This is a conclusion so radical that it undermines the very notion of an objective external world. But the terror goes even deeper. These same experiments, when analyzed fully, have revealed that individuals cannot even trust their own past observations. The researchers proved that one's own knowledge from a previous measurement cannot be reliably used in a present calculation. Using it would lead to a logical contradiction. This suggests that not only is reality observer-dependent, but that individual observers cannot maintain a consistent, coherent knowledge about quantum systems over time. The implications of this attack, the very foundation of personal identity and our sense of a continuous experience. If you cannot trust your own memories of past quantum measurements, what does that say about the reliability of your consciousness itself? Are we living in a universe where even our own personal experiences are fundamentally unreliable, where the past is as fluid and undetermined as the future? These discoveries have forced physicists to confront what they call the hard problem of consciousness from a new and terrifying angle. Quantum mechanics seems to require conscious observers to function. They must collapse the wave function and create a definite reality. But consciousness itself remains completely mysterious. We don't understand what consciousness is, how it emerges from matter, or why it appears to play such a fundamental and seemingly impossible role, a role in determining the nature of physical reality. The measurement problem has been tormenting physicists for nearly a century. But recent theoretical and experimental developments have made it utterly impossible to ignore. As our quantum technologies become more sophisticated and our experiments more precise, the contradictions at the heart of quantum mechanics become more apparent. They become more measurable and more profoundly disturbing. We are approaching a crisis point in physics, a moment when our most successful and accurate scientific theory is revealing logical contradictions that threaten the entire scientific worldview. The solutions being proposed by serious physicists require abandoning the most basic assumptions about reality and about consciousness and causality that have guided human thinking for centuries. Some physicists suggest that we need entirely new mathematical frameworks, perhaps frameworks based on logics that allow for true contradictions to properly describe quantum mechanics. Others propose, in all seriousness, that consciousness might be a fundamental feature of the universe, as basic as mass or electric charge. Still others argue that we simply need to accept that an objective reality, one that exists independently of our observation of it, simply does not exist. But perhaps the most terrifying possibility is that all of these radical solutions might be correct simultaneously. That we are living in a universe so strange, so fundamentally alien to human intuition that our minds simply cannot grasp its true nature. That the comfortable, predictable, classical reality we experience every day is nothing more than a simplified, user-friendly approximation of something far more bizarre and unsettling. The quantum measurement problem isn't just a puzzle for physicists to solve. It's a window into the deepest mysteries of existence itself. And what we are seeing through that window is forcing us to question everything we thought we knew. We are questioning everything about reality, consciousness, and our own place in the universe. But this is just the beginning. The measurement problem, as disturbing as it is, represents only one facet of the quantum terror that's keeping scientists awake at night. There are other paradoxes, other experimental results, other theoretical predictions that suggest reality is far stranger and more frightening than we ever imagined. What happens when quantum mechanics is applied to black holes? What occurs when we try to understand the fundamental nature of space and time themselves? And what are the implications of recent discoveries that suggest the entire universe might be fundamentally unstable? What if it is capable of spontaneously destroying itself through purely quantum processes? The terror extends far beyond the confines of laboratory experiments. deep in the heart of black holes, gravity becomes so intense that not even light can escape. There, quantum mechanics reveals its most nightmarish and reality-bending implications. For decades, physicists believed they had a basic, if incomplete, understanding of these cosmic monsters. Matter falls in, gets crushed to an infinite density at a central singularity, and disappears from our universe forever. It was a simple, brutal, and final story. But Stephen Hawking shattered that comfortable certainty. He did so in one of the greatest intellectual achievements of the 20th century. His calculations combined quantum field theory with Einstein's general relativity. They revealed that black holes are not entirely black. They emit a faint thermal glow now known as Hawking radiation. And through this process, they slowly evaporate over cosmic timescales until they vanish completely. This discovery should have been celebrated as a magnificent triumph of theoretical physics. Instead, it created what scientists now call the black hole information paradox, a contradiction so fundamental that it threatens to destroy our entire understanding of physical law itself. Here's the problem that is keeping physicists awake at night. When matter falls into a black hole, it carries information with it. The specific quantum state of every particle, every bit of data about its properties and its history, seemingly gets trapped forever. It is trapped behind the one-way membrane of the event horizon. But when the black hole evaporates through the emission of Hawking radiation, that radiation appears to be completely random. It appears to be thermal noise. It carries no information about what fell into the black hole in the first place. The information, it seems, just vanishes. This might sound like an abstract academic concern, but for a physicist, it is a catastrophe of the highest order. The conservation of information is one of the most fundamental bedrock principles in the entire universe. In every other physical process we have ever observed, information is always preserved. It might get scrambled, encrypted, or transformed into different forms, but it never truly, completely disappears. The laws of physics demand that if you know the current state of any system with perfect precision, you can in principle calculate its entire past and future. You can do so with complete accuracy. Black holes seem to violate this principle completely. They appear to be cosmic information destroyers. They erase the quantum fingerprints of everything that falls into them. If this is true, then the predictable deterministic universe that physics describes is an illusion. Causality itself breaks down when information can simply cease to exist. Recent research has proposed solutions that are somehow even more disturbing than the original problem. One leading hypothesis emerging from string theory suggests that space-time itself is quantum entangled. The very geometry of space and time emerges from deeper, more fundamental quantum connections that we don't yet understand. In this radical picture, the information that falls inside a black hole becomes deeply entangled. It becomes entangled with the structure of space-time outside the black hole. Think about what this means. Space and time might not be real in the way we think. They are the fundamental, seemingly passive stage on which all physical processes play out. They might be emergent properties of some deeper quantum mechanical structure, a vast network of entangled information that operates according to rules we haven't yet discovered. The distance between objects, the very flow of time, the three dimensions we move through, all of it could be illusions. It could be a holographic projection created by quantum entanglement patterns that exist outside of our normal experience. If this hypothesis is correct, then the information that falls into black holes isn't actually destroyed. It's encoded in tiny, imperceptible perturbations in the geometry of space-time itself. When the black hole evaporates, the information is preserved. It is preserved in the subtle quantum correlations between different regions of space and time. The universe maintains its precious information, but it does so only by making reality itself fundamentally quantum mechanical and perhaps holographic at its deepest level. Scientists find this possibility terrifying. It suggests that everything we think we know about the nature of space and time is fundamentally wrong. The solid, predictable classical framework that supports all of physics might be nothing more than a convenient approximation, an approximation that breaks down completely when we look too closely at the quantum foundations of reality. But even this mind-bending solution doesn't address the deepest horror, a horror that is hidden within the mathematics of quantum mechanics. There is a process so catastrophic, so utterly and completely destructive, that it could erase not just information, it could erase the entire universe itself. It is called false vacuum decay, and it represents the ultimate quantum nightmare. The idea is deceptively simple. Our entire universe, with its specific set of physical laws and fundamental constants, might be trapped. It might be trapped in what physicists call a false vacuum state. Like a ball balanced precariously in a shallow dip on the side of a very large hill, we appear to be stable, but we are actually in a profoundly precarious position. At any moment, without any warning, quantum mechanics could allow the universe to tunnel through the barrier. It could roll down to a lower energy, more stable state at the bottom of the hill. This isn't a gradual process. If a false vacuum decay begins, it creates an expanding bubble of altered space-time. This bubble travels outward at the speed of light. Inside this bubble, the fundamental constants of physics change. The forces that hold atoms together become different. The particles that make up matter transform into new alien forms. Everything we know, everything we are, everything that has ever existed in our universe would be instantly and completely annihilated. It would be replaced by a new universe with completely different physical laws. The most terrifying aspect of this is that the process is entirely random and unpredictable. Quantum mechanics allows for spontaneous tunneling events that could trigger a false vacuum decay at any moment, anywhere in the cosmos. There would be no warning, no way to prepare, no possibility of escape. The bubble of cosmic destruction would expand at the speed of light. So even if we could somehow detect it coming, we would be destroyed in the exact same instant that we received the information. Our final moment of awareness would be the moment we discovered our doom was upon us. Recent advances in quantum computing have made this theoretical horror more concrete and immediate. Scientists have successfully simulated false vacuum decay using quantum machines. They have created microscopic, harmless versions of the cosmic bubbles of death that could destroy everything. These simulations prove that the process is not just mathematically possible, it is physically realizable under the right conditions. The researchers describe a chilling experience watching these simulations unfold. They're not just studying abstract mathematics anymore. They're observing actual physical processes that mirror exactly what could happen to our universe at any moment. Each simulation is a miniature version of a cosmic annihilation, a practice run for the end of everything. What makes this even more disturbing is the realization that a false vacuum decay might have already occurred multiple times in our universe's own history. The Big Bang itself could have been the result of a false vacuum transition, a transition that reset the physical constants and created the specific reality we inhabit today. Previous versions of the universe might have been completely erased. These versions, with different laws of physics and different forms of matter and energy, might have left no trace of their existence behind. This possibility suggests that universes themselves are temporary ephemeral structures that spontaneously appear and disappear through quantum mechanical processes. That consciousness, life, stars, galaxies, everything we consider to be permanent and meaningful exists only in the brief, fragile intervals between these cosmic resets. We might be living in a universe that is already doomed. We might be counting down to an inevitable quantum apocalypse that will erase all evidence that we ever existed. The false vacuum decay scenario reveals something profound about the very nature of quantum mechanics. It's not just a theory about tiny particles behaving strangely, it's a description of fundamental processes that can operate on any scale, from the subatomic to the truly cosmic. The same bizarre quantum rules that govern the behavior of electrons in laboratory experiments also govern the ultimate stability of the entire universe. This deep connection between the microscopic and the cosmic is precisely what makes quantum mechanics so terrifying to scientists. The weird counterintuitive behaviors they observe in their laboratories are not confined to those specialized experimental conditions. They are expressions of universal fundamental principles that apply everywhere at all scales at all times. The strangeness of quantum mechanics isn't a curiosity. It is the fundamental nature of reality itself. But there's another quantum effect that is perhaps even more unsettling than a false vacuum decay. It is called the quantum Zeno effect. It demonstrates that the act of observation can literally freeze physical processes in time. Named after the ancient Greek paradoxes about motion, this effect shows that a frequent measurement can prevent a quantum system from evolving naturally. Here's how it works. A quantum system naturally evolves from one state to another over time. An unstable particle will decay. An excited atom will emit a photon. A quantum system will transition between different energy levels. But if you measure the system frequently enough, these natural processes simply stop occurring. The measurements effectively freeze the system in its original state. They prevent it from evolving according to the normal laws of physics. This isn't just a theory. Scientists have observed the quantum Zeno effect in dozens of different systems. They have used frequent measurements to prevent particle decay, to stop atomic transitions, and to freeze a quantum evolution in its tracks. The effect is real, measurable, and completely contradicts our intuitive understanding of how time and causality should work. The terrifying implication is that a conscious observation has the power to alter the flow of time itself. By choosing when and how often to measure a quantum system, an observer can control whether natural physical processes occur or not. This gives consciousness a kind of a godlike power over the evolution of a matter and an energy. It suggests that the boundary between a mind and a physical reality might be far more porous than we had ever imagined. Modern quantum physicists are now actively exploiting this effect to control quantum systems. They control them in ways that would have seemed like pure magic just decades ago. They use carefully timed measurements to manipulate the evolution of quantum computers. They use them to create exotic states of matter, and even to attempt to build quantum technologies that operate by preventing natural processes from occurring. The widespread observation of the quantum Zeno effect across different physical systems confirms that the power of an observation to alter a reality is a fundamental feature of a quantum mechanics. It is not just a theoretical curiosity. It suggests that a consciousness and a physical reality are interconnected in ways that a science is only beginning to explore. This brings us to perhaps the most mind-bending quantum paradox of all. The delayed choice quantum eraser experiment appears to demonstrate that a present-day decision can influence an event that occurred in the past. The setup involves quantum particles that travel through a double-slit apparatus. This creates an interference pattern that proves they behaved like waves. But here's where it gets impossible. Scientists can choose whether to measure which path each particle took. They can choose this after the particles have already passed through the slits and been detected. If they decide to measure the path information, the interference pattern disappears. This suggests the particles behaved like particles rather than waves. If they decide not to measure the path information, the interference pattern remains. This confirms a wave-like behavior. The particles seem to know what measurements will be performed on them in the future. They seem to adjust their past behavior accordingly. This suggests that the fundamental principle of causality might not hold at the quantum level. The principle states that a cause must precede an effect. The future appears to be influencing the past in ways that completely undermine our understanding of a temporal order and a logical reasoning. Scientists have performed increasingly sophisticated versions of this experiment. They have confirmed that the effect is real and measurable. They have created situations where the choice of whether to erase a path information is made by a random number generator. This is done after the particles have already been detected. This eliminates any possibility that the particle could somehow know in advance what a measurement would be performed. The result, a consistently A, shows a violation of a classical, a causality, a present day, a choice, and appears to a retroactively, a determine the A, past, a behavior of a quantum, a particle. This creates a form of a backward in time, an influence that challenges and everything we think we know, everything about the nature of a time and a causation. These experiments force us to confront a possibility that a common sense, a notion of a cause and an effect is fundamentally flawed. It is flawed when applied to a quantum, a mechanical, a system. A time itself, a might, not a flow in the linear, a predictable, a manner we, an experience in an everyday life. The a past, a present, and a future. A might be an interconnected in a way that A makes a temporal, a paradox, not just a possible, but an inevitable. The accumulative, an effect of these, a quantum, a paradox, is creating an existential crisis in a physics. The A measurement, a problem, an information, a paradox, a false, a vacuum, a decay, the A quantum, a xeno, an effect, and a retrocausal, a quantum, a erasure, is all pointing towards the A same, a terrifying A conclusion. A reality is nothing like what we thought it was. The scientist at the University of Vienna has pushed this terror to its logical and extreme. They've proven that the A contradiction in a quantum, a mechanics, isn't just a theoretical problem. A problem that might be solved with a better, a mathematics, or a sophisticated an experiment. They're a fundamental, a feature of a reality that A cannot be eliminated. It cannot be eliminated without abandoning a basic, a principle that A makes a science possible. Their work demonstrates that no interpretation of a quantum, a mechanics, can preserve all the assumption we consider an essential for a rational, a thought, and either an objective, a fact doesn't exist, or an observer doesn't have a free will to choose an experiment. Or an information can travel instantaneously across any distance in the A universe. Pick your A poison because one of these cherished A belief A must be A sacrificed. But the A horror doesn't stop with a philosophical implication. These quantum paradox is beginning to manifest in the A real world. They do so through an advancing technology. As we build more sophisticated a quantum, a computer, and a measurement, a device, we're creating a system that operates A, according to these, A, terrifying, a quantum, a rule, not the A, comfortable, A, classical, A, physics of R, an everyday, an experience. A quantum, a computer, doesn't just process an information differently than a classical computer. It processes an information that exists in a multiple, a contradictory, a state simultaneously. It performs a calculation on a possibility rather than an actuality. It manipulates a quantum, a superposition that shouldn't exist. According to an intuitive, an understanding of a logic and a mathematics. When a computer runs an algorithm, it's not following a sequence of a logical step. It's an exploring, a multiple, a computational, a pathway simultaneously. It is an existing in a superposition of a having, a found, and not a found, an answer. This happens until the final measurement. Collapses the system into a definite result. The computer, literally doesn't know what a calculation it has performed until someone observes the outcome. This creates a nightmarish scenario for a technological future. We're building a machine whose fundamental operation depends on a quantum, a mechanical principle that we don't understand, and that appears to violate a basic logic. These computers can solve a certain problem, and exponentially faster than any classical computer. But they do so by exploiting a quantum, an effect that seems to allow them to cheat the normal, a rule of a computation, the implication. Extends afar, beyond a computer, a science. A quantum, a technology is beginning to permeate every aspect of a modern life, from a medical, imaging, a device, to a GPS, a satellite, to a secure, a communication, a network. Each of these technology operates by manipulating a quantum, an effect that contradicts our basic, an understanding of how the physical world should behave. We're becoming increasingly dependent on a technology that works through a mechanism we cannot explain, a mechanism using a coherent, a physical, a principle. Our most advanced tool is based on a quantum, a mechanics. But a quantum, a mechanics itself, contains a logical, a contradiction that threatens the foundation of a scientific reasoning. This technological, dependence on an incomprehensible, a quantum, an effect, creates a new, a form of an existential, a vulnerability. We're building a civilization that operates, according to a physical, a principle that appears to be fundamentally irrational. Our most important technology works, but we don't know why they work, nor do we know whether they will continue working as we push deeper into the quantum realm. An economic implication is staggering. An economist predicts that the widespread adoption of a quantum technology could trigger what they call a quantum, a productivity, a paradox. Just as an introduction of a computer initially decreased productivity before, and eventually revolutionizing an economy, a quantum, a technology, a might, a cause, a massive, an economic, a disruption. This could happen before their benefit. Becomes an apparent. But a quantum, a productivity, a paradox could be far more severe than a previous, a technological, a transition, a digital, a computer for all there, a complexity, a still, operates according to a logical, a principle that a human can understand. A quantum, a computer, operates according to a principle that appears to contradict a logic itself. This, a disconnect between a human, an understanding, and a technological, a capability, creates an unprecedented risk. We're developing a tool that we cannot fully control or predict. This is because they operate according to a quantum mechanical, a rule that we don't comprehend. The more powerful, these technology, becomes the more we depend on a physical process. a process that A seems to defy a rational an explanation. The A terror, A deepens, when we consider that a consciousness itself, A, might be a quantum, a mechanical, a phenomenon. Some scientist proposes that the stranger property of a quantum, a mechanics, suggests that a consciousness, plays a fundamental role. This is particularly the role of an observation in determining an outcome. It suggests a consciousness plays a fundamental role in the A structure of a reality. If a consciousness is a quantum, a mechanical, then the A paradox and a contradiction that plague an understanding of a quantum, a physics, also apply. They apply to the nature of a mind itself. The A measurement, a problem, A, becomes a consciousness, a problem. The an observer, a dependence of a quantum, a reality, A, becomes a statement. A statement about the A fundamental, A, nature of a subjective, an experience. This possibility suggests that the A crisis in a physics is also a crisis in an understanding of ourselves. If a quantum, a mechanics, and accurately A describes a consciousness, then our A sense of a being, a unified, a consistent, an observer, A might be an illusion. We might exist in a quantum, a superposition of a different, a mental, a state. This would last until the act of an introspection forces our mind to collapse into a definite, a thought and an experience. The implication is psychologically devastating. If a consciousness is a quantum, a mechanical, then the continuity of a personal, an identity that we take for granted might be fundamentally an illusory. Each moment of a conscious an experience might involve a quantum, a collapse that determines not just what we observe but who we are as an observer. A recent research in quantum biology has discovered a quantum, an effect, an operating in a living system, from a photosynthesis in a plant to a navigation in a bird to possibly even a neural, a process in the human, a brain. These discoveries suggest that a life itself might be a quantum, a mechanical, a phenomenon that operates according to the same, a paradoxical, a rule that governs a particle, a physics. If a biological process is a quantum, a mechanical, then the strange, a property of a superposition, an entanglement, and a measurement induced a collapse, might be an operating continuously within our own, a body, a biological, a decision from the firing of a neuron to the folding of a protein, might, involve a quantum, process that exists in a multiple state simultaneously until it collapses into a definite outcome. This quantum biology creates a terrifying picture of a life as a collection of a quantum, a system that exists in a constant, a superposition, a system, a making, a probabilistic, a transition between a different, a possible, a state. We might not be the coherent, a unified, a being we imagine ourselves to be. We may be rather a quantum, a phenomenon that temporarily coalesces into an appearance of a stable, a biological, an entity. The discovery of a quantum, an effect in a biological system also raises a disturbing question about a free will and a determinism. If our brain operates according to a quantum, a mechanical, a principle, then our thought and a decision might be a fundamentally random, not determined by a logical reasoning or a conscious, a choice. A quantum, a mechanics, and includes a genuine, a randomness, a randomness that cannot be predicted or controlled, and even in a principle. If a consciousness, A, depends on a quantum, a process, then our, a mental, a life, a might be, are governed by this, a fundamental, a randomness, not by the A rational, A decision-making, a process, we, an experience, A subjectively. This, a quantum, a randomness in a consciousness, couldn't explain why a human, a behavior, an often, an appears, an irrational, or an unpredictable. We, a might be, a quantum, a system that occasionally collapses into a coherent thought and a decision. But we may spend most of our time existing in a superposition of a different, a possible, a mental, a state. The A philosophical an implication and attacks the very A foundation of a human, an identity and a moral, a responsibility. If an action is determined by a quantum, a randomness, rather than a conscious, a choice, what does that mean for a concept like a guilt? What does it mean for a praise, a punishment, and a personal, a growth? Are we responsible for a decision that A might be, a fundamentally a random, a quantum, an event? These questions become an even more disturbing when we consider that a quantum, mechanics, might apply not just to an individual, a consciousness. It might apply to a collective, a human, a behavior, and a social, a system. If a group of people can become a quantum and entangled through an interaction, then a social, a phenomenon, a might, and exhibit the same, a paradoxical, a property that governs a quantum, a particle. A quantum, a social, a system could exist in a superposition of a different, a collective, a state. This could last until a measurement or an observation forces them to collapse into a definite, a social, a reality. An election, a market, a cultural, a movement, and a historical, an event, might be a quantum, a mechanical, a process that operates according to a probability, a distribution, not a deterministic, a cause, and an effect, a relationship. This a quantum, a view of a society, suggests that a social, a reality itself, might be an observer-dependent, and a fundamentally an uncertain, a different, an observer, a might, a legitimately a disagree about a social, a fact. They could disagree in the same, a way that a quantum, a physicist can, disagree about an outcome of a quantum, a measurement. An implication extends to an understanding of a history, a culture, and a human, a progress. If a social, a system is a quantum, a mechanical, then a past, a might, exist in a superposition. It could exist in superposition until a historical, an observation, collapses it into a definite, a narrative. The future, might be a fundamentally, an undetermined. It may be an existing as a probability, a distribution over a possible, an outcome, not a following, a predictable, a trajectory. These, a quantum, a social, an effect, couldn't explain why a human, a society, and often behaves in an apparently an irrational a way that contradicts an economic, a model, and a political, a theory. We might be trying to understand a quantum, a phenomenon, using a classical, a reasoning. This could lead to a systematic, a failure in a prediction and a control. The cumulative, an effect of these. A discovery is creating a comprehensive, a crisis in a human, an understanding. A quantum of mechanics isn't just a changing of physics, it's a potentially a revolutionizing an understanding of a consciousness, a biology, a technology, a society, and a reality itself. We're discovering that the quantum, a weirdness that a physicist observes in there, a laboratory might be an operating at every level of an existence, from a subatomic, a particle to a human, a consciousness to a social, a system, to a structure of the universe itself. A comfortable, a predictable, a reality of a classical, a physics, a might be, and nothing more than an approximation that breaks down when we look closely at any phenomenon. This, a quantum, a revolution, is a happening, whether we're ready for it or not. Our technology is becoming an increasingly a quantum, a mechanical. An understanding of a biology is a revealing a quantum, an effect in a living a system. And an exploration of a consciousness is an uncovering, a quantum, an aspect of a mental, an experience. But we're approaching these a quantum, a phenomenon with a mind that evolved to understand a classical, a reality. We're trying to comprehend a quantum, a superposition, an entanglement, and a measurement-induced collapse. We do this using a cognitive, a tool that developed to track an object, and to predict a trajectory and understand a cause and an effect, a relationship in a classical world. This a mismatch between a quantum, a reality, and a classical, an intuition, creates a fundamental, an epistemological, a crisis. We might be living in a universe that's an alien to a human, a cognition. So alien that we simply cannot understand it. Using the mental category and a logical structure that feels natural to us. The terror isn't just that a quantum of mechanics is strange. The terror is that a quantum of mechanics might be a description of a reality, and a reality might be fundamentally incomprehensible to a human mind. We might be a conscious, a quantum, a system trying to understand ourselves, using a classical, a concept that is fundamentally inadequate for the task. This a possibility suggests that the current crisis in a physics is just the beginning. As we continue to explore a quantum, a phenomenon at a larger scale and in a more complex system, we're likely to encounter a paradox and a contradiction that is even more disturbing than anything we've discovered so far. The quantum, a rabbit, a hole, and appears to go all the way down. It is leading to an implication that challenges not just our scientific, a theory. It challenges our most basic, an assumption about the nature of an existence, a consciousness, and a knowledge itself. We're standing at the edge of a conceptual, an abyss that might be too deep for a human, an understanding to fathom, and yet we cannot turn back. Our survival as a technological, a civilization, depends on mastering a quantum, a technology that operates according to a principle we don't understand. We're locked into a trajectory that will force us to confront a quantum, a reality. We must confront it whether we're psychologically prepared for it or not. The next phase of a human, a development, a might, require us to abandon a classical, a worldview that has guided a human thinking for millennia. And we may need to learn to think in a genuinely quantum term. But making that a transition could fundamentally alter what it means to be a human. We might need to become a quantum, a being to survive in a quantum, a universe. But the process of a quantum, an evolution, a might, an erase, and everything that we currently consider essentially a human, it may replace a classical, a consciousness with something, a quantum, a mechanical, something that we cannot and imagine or comprehend. This is the unultimate, a quantum, a paradox, an understanding, a quantum, a reality, a might, require, sacrificing our, humanity, but a remaining, a human, might, condemn us to a permanent, an ignorance about the true, a nature of the universe we and inhabit. The a choice, if it is a choice at all, a might and already be a determined by a quantum, a mechanical, a process that an operates, beyond the reach of a classical, a reasoning and a conscious, a decision-making. We a might be a quantum, a system, an evolving according to a probability, a distribution that we cannot control or predict. The quantum, a revolution, is in transforming an everything, whether we embrace it or resist it. The only a question is a whether will maintain any, recognizable, a human, an identity. As we're swept along by a quantum, a force that operates according to a rule that transcends a classical, an understanding, but this, a transformation, is an accelerating. The quantum, an effect, is a becoming more an apparent and more an unavoidable with each, a passing a year. The time for a comfortable, a classical, an assumption is an ending. The age of a quantum, a reality, has an already begun. The an implication, becomes an even more, a terrifying when we examine what a physicist calls the Copenhagen, an interpretation. This remains the most popular way of an understanding, quantum, mechanics. It is accepted by nearly a half of all, an experimental, physicist, but a popularity doesn't make it any less disturbing. According to a Copenhagen, a quantum, a system, doesn't have a definite property until it's measured. The wave, a function that describes a particle's a quantum, a state, represents a pure, a possibility. It is a mathematical, a ghost that haunts the space between an existence and a non-existence. Only when we observe the system does a reality crystallize into something, a definite and a measurable. Think about what this means for the world. Around you. Every an atom in your body, every a photon of a light hitting your eye, every an electron flowing through your device, and exists in a quantum, a superposition. It exists in superposition until the moment of an observation forces it to choose a definite, a state. The solid matter, your sitting on the air, your breathing, the screen, your reading this from. All of it is constantly flickering. It is flickering between an existing and not an existing at the quantum level. But here's where the terror deepens. The Copenhagen, an interpretation, can't explain what constitutes a measurement. Wherean exactly does the quantum, a world, an end, and the classical, a world, begin? When does a superposition, a collapse into a definite reality? Is it when the photon hits your retina, when the signal reaches your brain? When you have become consciously and aware of seeing something, the boundary between a quantum and a classical, a reality is completely an arbitrary. We draw the line wherever it's convenient for our calculation, but there's no physical principle that determines where quantum weirdness stops, nor where a normal reality begins. This means that the comfortable, a classical, a world of our and every day, an experience, a might be, and nothing more than a useful fiction. Some an interpretation, pushes this a logic to its an ultimate, a conclusion. If a quantum, a mechanics, an applies to an everything, then you as an observer, a, must also be a quantum, a system. Your a, brain, your a, consciousness, your a, various sense of a self, and exists in a superposition. It exists until the a moment you an observe, a yourself, a thinking, but a who or a what is a doing, the an observing. This a creates an infinite, a regress of an observer, an observing, an observer. To a measure your a, own, a quantum, a state, you, a need, a higher level, an observer, but that an observer also needs to be an observed by a yet another an observer. The hierarchy of a consciousness a required to a collapse, a quantum, a superposition, an extends an infinitely and upward. It has no an ultimate, a ground for a reality to arrest a upon. A recent an experiment has made this a philosophical, a nightmare, a concrete. A scientist has created a situation where a human, an observer, genuinely disagrees about the an outcome of a quantum, a measurement. They disagree not because of an experimental, an error, or a miscommunication. They disagree but because a reality itself appears to be an observer dependent. In these, an experiment one, a scientist, a makes a measurement, a inside, a sealed a laboratory. Another, a scientist, an outside, treats an entire lab as a quantum, a system. From the an inside a perspective, the a measurement has a definite an outcome. From the an outside a perspective, the a lab, a remains in a superposition. The a scientist, a inside, a existing in a quantum, a mixture of a having an observed a, different a, result. A, both a perspective is a, mathematically a, valid a, according to a quantum, a, mechanics. A both an observer is a following the a same, a physical, a law, and a, using the a same, a scientific, a method. But they reach a contradictory, a conclusion about what an actually a happened. This isn't a failure of the an experimental a design. It's a feature of a quantum, a reality itself. An implication a extends afar, a beyond, a laboratory, a condition. If a consciousness a plays a fundamental a role in a quantum, a mechanics, then every a conscious a being is a constantly a making a quantum, a measurement. They do so simply by a being and aware. Your a thought, a perception, and an experience is a continuously a collapsing, a quantum, a superposition throughout your an environment. But a different, a conscious, an observer, a might, a collapse, a same, a quantum, a system, in a different a way. This would create a multiple, an incompatible, a version of a reality that somehow coexist without a logical contradiction. The a universe, you, an experience a, through your a, consciousness a, might be a fundamentally a different from the a universe, and experienced by someone a, standing a, right a, next to you. This an observer, a dependence of a reality, creates what a physicist calls a problem of an intersubjective, an agreement. If a reality is a different for each, an observer, how do we ever agree on anything? How is a communication possible between a being who might be living in a genuinely a different version of the a universe? An answer, a, seems to be that an agreement is only an approximate and a temporary. The a classical, a world of a shared an objective, a fact, and emerges as a kind of an average, or it emerges as a consensus, a reality that glosses over a deeper, a quantum, a disagreement between a different, an observer. But this, a consensus, is a fragile, and a breaks down when we, a probe, a quantum, a system, a two, a precisely. We're discovering that the asocial, a construction of a reality, isn't just a philosophical, a metaphor. At the a quantum, a level, a reality, a literally is a constructed. It is constructed through the ain, interaction between a conscious, an observer, the an objective, a physical, a universe, that a science, a claims to a study, a might be a nothing more than a collective, a hallucination, a shared by a quantum, a being, who can a never a fully an access, and each and others a subjective, an experience. This a quantum, a subjectivity, a becomes an even more a disturbing when we consider it's an implication for a memory and a personal, an identity. If your a brain is a quantum, a system, then your a memory and exists in a superposition. It exists in superposition until the a moment you recall them. The act of a remembering doesn't just retrieve an information about the past. It literally creates the past by collapsing a quantum, a superposition of a possible history. Every time you remember something, you're potentially selecting one, a version of your personal history, a version from a quantum, a superposition of a different, a possible, a past, your an identity, your a sense of a continuity through a time, your an understanding of a who you are and a how you gotta hear. All of it, might be a continuously, a reconstructed. It is reconstructed through a quantum, a measurement, a performed by your own, a consciousness. A research, suggests that this isn't just a speculation. A scientist studying the quantum, a property of a microtubule in a brain, a neuron, has found an evidence that a quantum, an effect, a might, a play, a crucial role in a consciousness and a memory, a formation. If these findings are confirmed, then our mind operates according to the same paradoxical quantum, a rule that governs a particle, a physics. This would mean that a stream of a consciousness, an experience as a unified, a continuous, a flow of a thought and a perception, is actually a series of a discrete, a quantum, a collapse. Each a moment of an awareness and involves a quantum, a measurement that selects one, a possibility from a vast, a superposition of a potential, a mental, a state. An implication for a freer will is a catastrophic. If our decision emerges from a quantum, a process, then they might be fundamentally random, not determined by a rational deliberation. A quantum, a mechanics, and includes a genuine and irreducible randomness that cannot be predicted, and even in a principle. If a consciousness depends on a quantum, a randomness, then our choice might be no more determined than the decay of a radioactive atom. But the terra goes deeper than a randomness. A quantum mechanics also includes a non-local, a correlation that transcends a space and a time. If a consciousness is a quantum, a mechanical, then your thought and a decision might be instantaneously correlated with an event, a happening, and anywhere in the universe. This would create a web of a quantum, an entanglement that connects all, a conscious, a being. This, a quantum, an interconnectedness, could explain a phenomenon that a classical, a physics, a cannot, an account for, a telepathy, a precognition, and a collective, an unconscious, and a morphic, a resonance, and an other, a paranormal, a claim. These might be a manifestation of a quantum, a correlation between a different, a conscious, an observer. But this, a connection, A, comes at a price. If a consciousness is a quantum and entangled across a space and a time, then an individual, an identity, A, becomes a meaningless. Your A, thought, and an experience, A, might be A, fundamentally an, inseparable from the A, mental, A, state of every, an other, A, conscious, A, being, every other conscious being in the A, universe. The boundary between a self and another dissolves at the quantum level. The A, philosophical an implication, and attacks the A, very A, foundation of a human, an experience. If a quantum, a mechanics, and accurately A describes a consciousness, then an everything we consider an, essentially a human, might be a classical, an illusion. This includes an individual, an identity, to a rational, a thought, to a moral, a responsibility. It is an illusion that emerges from a deeper, a quantum, a process we cannot understand or control. This, a quantum, a view of a consciousness, also raises a terrifying a question about a death and a survival. If a consciousness is a quantum, a phenomenon, what happens when the A physical, a brain, A stops functioning? Do the A quantum, a correlation that constitutes a mind, persist after a biological death? Could a consciousness exist in some a quantum, a form that transcends an individual, a brain? Some an interpretation of a quantum, a mechanics, suggests that an information A cannot be destroyed, it can only be transformed. If a consciousness is fundamentally an informational, then a death might not be the end of a mental existence. It may be a transition to a different, a form of a quantum, an information, a processing. But this a quantum, an afterlife, would be nothing like a traditional, a religious, a concept of a survival. It would be a realm of a pure quantum, an information and existing in a superposition across a multiple, a possible, a state simultaneously. An individual, an identity would be meaningless in such a realm. This is as a quantum, an information can be copied, merged, split, and transformed in a way that a classical, a mind, cannot comprehend. The possibility of a quantum, a consciousness, also creates a new, a form of an existential, a terror. If your mind is a quantum, a system, then it might be possible for an external, an observer, to manipulate your mental state. They could do this by making a measurement on a quantum, a system, and entangled with your A brain. Your A thought, a memory, and a decision could be altered without your A knowledge. Altered through a quantum, an interference, an effect, an advanced, a quantum, a technology, a might, and eventually, allow for a direct, a manipulation of a consciousness itself. A quantum, a computer, could potentially simulate a human, a mind. It could create an artificial, a consciousness, or a transfer, a mental, a pattern between a different, a physical, a substrate. The boundary between a natural and an artificial, a consciousness, would dissolve. This would happen as a quantum, an information, a processing A, becomes more sophisticated. These technology could enable a form of a mental, an existence that is impossible for a biological brain. A quantum, a mind, could exist in a superposition. It could experience a multiple, a stream of a consciousness simultaneously. They could, become entangled with another, a mind, a sharing, a thought, and an experience. Directly, they could manipulate their own, a quantum, a state, to alter their memory, a personality, and a decision-making, a process. But these, a quantum, an enhancement of a consciousness, a might, come at the cost of an everything, we consider an essentially a human, a quantum, a mind, a might, be more powerful than a biological, a brain. But it would operate, according to a principle that is a fundamentally alien to a human, psychology. The transition from a biological to a quantum, a consciousness, might be an irreversible. It might be an impossible to a return to a once a mind, becomes a quantum, a mechanical. To return to a limited but a comprehensible an experience of a classical an awareness. An enhancement, might be a permanent. It would be a transforming a human, a consciousness, into something that can no longer relate to its a biological an origin. This creates what a researcher calls a quantum, a consciousness, a paradox, an understanding, a quantum, a reality, a might, require, a becoming, a quantum, a being. But the process of a quantum, a transformation, a might, destroy, and everything that makes us a human, we might gain an access to an ultimate, a truth about the nature of a reality, but we may lose our humanity in the process. The paradox and extends to an entire civilization. An advanced, a quantum, a technology, a might, a solve every material, a problem, it could, an eliminate, a scarcity, a cure, a disease, a reverse, an aging, and a provide an unlimited, a clean, an energy. But in achieving these a benefit, a might, require, transforming a human, society into something, a quantum, a mechanical, something that operates according to a principle that transcends a classical, an understanding. We might be approaching a phase, a transition in a human, an evolution, a transition where a classical, a consciousness, gives way to a quantum, an awareness. But this a transition might be an irreversible, and we have no way of knowing whether a quantum, a being would consider there an existence, an improvement over a tragic, a human, a consciousness, or a loss of an everything that made a life a meaningful. The quantum, a future, is an approaching whether we choose it or not. Our technology is a becoming an increasingly quantum, mechanical. An understanding of a biology is a revealing a quantum, an effect in a living a system, and an exploration of a consciousness is an uncovering a quantum, an aspect of a mental an experience. We're a being swept along by a quantum, a force that operates according to a rule we don't understand and cannot control. The classical, a world of a predictable a cause and an effect, is a giving away to a quantum, a reality of a superposition, an entanglement, and an observer-dependent an outcome. The scientist who studies these a phenomenon is terrified not just by their strangeness, but by their an implication for the future of a human, a consciousness, and a civilization. We're discovering that a reality is a nothing like what we thought it was, and the process of discovering the truth might transform us into something we cannot imagine. The quantum revolution is already underway, and there might be a path back to a comfortable, a certainty of a classical, a reality. We're a quantum, a being, a living in a quantum, a universe, and the time has come to confront the full, an implication of that, a fact, even if it means sacrificing an everything we once considered an essentially a human. The quantum revolution is consuming an everything. It consumes everything from the smallest particle to the largest structure in the universe, to a consciousness itself. We're discovering that the classical world we thought we inhabited was never real. It was just a temporary an approximation that's now a giving away to something, a quantum, a mechanical, something that transcends a human, an understanding. The A scientist, A studying these A phenomenon is a no longer A just an observing a quantum an effect. They are becoming a quantum an effect themselves. They are a transformed by their, an investigation into something that can comprehend a quantum, a reality, but it can a know, a longer, a relate to a classical, a human, an experience. This is the quantum a paradox that terrifies a scientist most of all. The truth about a reality might be inaccessible only to a being who is a longer a human in any recognizable sense. And understanding the universe, might require sacrificing our humanity itself, and that a transformation might be the price we must pay for a knowledge about the quantum, a nature of an existence. We might gain an access to an ultimate, a truth about a reality, but we may lose ourselves completely in the process. The quantum future is coming, and we might discover that a consciousness itself is just another quantum phenomenon, a subject to the same, a paradox, and an impossibility that governs an everything else. In this stranger universe, we're desperately trying to understand. But an understanding might transform us into something, a quantum, a mechanical, something so an alien to a human, an experience, so much so that the classical being we once were would no longer recognize what we've become. That might be the most terrifying quantum, an effect of all, the quantum nightmare, and extends even further when we examine what a physicist calls a vacuum, a decay, a process, a fundamentally destructive, that it could obliterate not just our universe, it could obliterate the very concept of an existence itself. This isn't some distant, a theoretical, a concern. A scientist hasn't actually simulated this, a cosmic, an apocalypse in a laboratory, using a quantum, a computer. They are watching in a fascination and a horror as they create a microscopic, a version of the bubble that could destroy everything. Here's what makes a vacuum, a decay, so terrifying. An entire universe might be balanced on a knife's edge. It may be trapped in what a physicist calls a false vacuum, a state. Think of it like a ball sitting in a shallow dip on a hillside. It looks stable, it feels permanent, but it's actually in a precarious position. At any moment without a warning, a quantum mechanics couldn't allow that ball to tunnel through the hill and to roll down to the true bottom. When that happens in our universe, the consequence is an absolute, a bubble of an altered space-time, begins expanding at the speed of light. It is rewriting the fundamental, a law of physics, as it grows. Inside this bubble, the force that holds an atom together changes. The particle that makes up a matter transforms into a new form. The constant that governs a chemistry and a biology becomes a different, a value. And everything we know and everything we are and everything that has ever existed would be instantly annihilated, and it would be replaced by a universe with a completely different physical law. The most horrifying aspect is that this process is an entirely random and an unpredictable. a quantum mechanics and includes a randomness that it cannot be a controlled or a predicted and even in a principle. A vacuum, a decay, an event that destroys our universe could happen right now. It could happen while you are reading these a word. It could have started 1 billion a year ago in a distant galaxy. The destruction, a wave, a racing toward us at a light, a speed, an invisible and an unstoppable. There would be no warning, no way to prepare, no possibility of an escape. The bubble of a cosmic, a destruction, travels at the ultimate, a speed, a limit of the universe. By the time we could, possibly detect it and approaching, we would be annihilated. We would be annihilated in that same, an instant. A final, a moment would be a moment we discovered a doom was upon us. A recent experiment has made this a theoretical, a horror, a tangible and a real. Using a quantum, a computer, called an annealer, a scientist, has successfully created and studied the formation of these cosmic bubble. They have done so under a controlled laboratory, a condition. They watch as a quantum field transitions from a false vacuum state to a true vacuum state. This forms an expanding region where the law of physics is fundamentally different. The researcher describes chilling an experience, watching these, simulation. They're not just studying an abstract mathematics anymore. They're observing an actual, a physical, a process that mirrors exactly what could happen. What could happen to our universe at any moment. Each simulation is a miniature, a version of a cosmic, an annihilation, a practice, a run for the end of an everything. These are quantum, a simulation, reveals a disturbing detail about how a vacuum, a decay would unfold. The transition isn't a gradual or a merciful, it's an instantaneous and a total. One a moment, the older physics, applies. The next a moment, a reality, operates. According to completely different rule. There's no intermediate, a state, no a transition, a period, no a gradual, a change. There is just a sudden and absolute transformation. But the terror deepens when we consider an implication of a quantum, a superposition for a vacuum, a decay. Before an observation or a measurement, a quantum, a system, and exists in all a possible state simultaneously. This means our universe might and already be in a superposition of having undergone a vacuum, a decay, and not having undergone a vacuum, a decay. A reality itself might and exist in a quantum, a limbo between an existence and an annihilation. This may last until some cosmic, a measurement, forces it to a collapse, into one a state or the other. The act of studying a vacuum, a decay, might itself be contributing to the probability. A probability that a vacuum, a decay will occur. The act of running these a quantum, a simulation of making a measurement on a quantum, a field, a state, might be contributing. Every a quantum, an experiment that probes the stability of a vacuum, a state, might be nudging the universe closer to the critical, a point where spontaneous, tunneling becomes an inevitable. A scientist finds themselves in an impossible position. They need to study a vacuum, a decay to understand a cosmic, a stability, and the long-term fate of the darker universe. But there an investigation, might be an increasing the risk of triggering the very catastrophe they're trying to understand. each a measurement, each a simulation, each a theoretical, a calculation, a might be, a bringing us a closer to a cosmic, an annihilation. This creates what a researcher calls an observation, a paradox of a vacuum, a decay. The A, more we, a learn about the A, stability of our A universe. The A, lesser stable we A, might be A, making it. A knowledge itself, A becomes a cosmic, a risk, a factor, a potential, a trigger for a universal, a destruction. The scientist studying these phenomenon is an acutely and aware that their A research, A might, and inadvertently A cause the an end of an everything. The quantum nature of a vacuum, a decay, also raises a disturbing question about the nature of an existence itself. If our A universe can spontaneously transition to a state with a different, a physical, a law, what does that say about the permanence of a reality? Are the fundamental, a constant that governs a chemistry and a physics just temporary, an accident that could change at any a moment? This quantum, an instability of a physical, a law, suggests that everything we consider a permanent and a reliable about the universe is actually a contingent and a fragile. The A speed of a light, the A strength of a gravity, the A mass of an electron, all the A constant. That A makes our A form of a matter and an energy. A possible A might be A, nothing more than a temporary A, value. A value in a cosmic, a lottery, that could be redrawn at an instant. A recent, theoretical work suggests that a vacuum, a decay, might not be a single an event. It might be a continuous process, occurring throughout the universe. A multiple, a bubble, a nucleation, an event might be happening constantly. This would create a cosmic, a foam of a region with a different, a physical, a law. Our unobservable, a universe, might be a just one, a bubble among a countless another, each an operating according to its own, a unique, a set of a physical, a constant. This a multiverse of a vacuum, a decay, a bubble, creates a nightmarish, a picture of an existence as an endless, a series of a temporary, a reality that spontaneously appears and disappears through a quantum, a mechanical, a process, a civilization, a galaxy, an entire, a cosmic, a history, might be constantly emerging and a being and erased. This could happen as a quantum, a field, a transitions between a different, a vacuum, a state. We might be living in a universe that's simultaneously a beginning and an ending at every moment, with a countless version of a reality, a blinking in and out of an existence. This could be happening through a vacuum, a decay, a process, and occurring at a scale we cannot detect. The A stable, a permanent, a cosmos we perceive might be an illusion created by our A limited, a perspective on a quantum, a process, and operating across a vast region of a space and a time. The possibility that our universe has already undergone a vacuum, a decay, a multiple, a time, raises an even more disturbing question. A previous, a version of a reality with a different, a physical, a law and a different, a form of a matter and a consciousness. A might have existed, they might have existed before our current, a cosmic, a phase, a began. These an earlier universe would have been completely erased. They would have left no trace of their existence in our current reality. This suggests that a consciousness and an intelligence might be a temporary, a phenomenon that emerge briefly between a vacuum, a decay, an event, and a phenomenon that isn't obliterated when the A next A phase of transition occurs. And everything we consider meaningful about an existence, from a love and an art to a science and a philosophy, might be a fleeting, a pattern that an emerge and accidentally in the A brief, an interval between a cosmic, a reset, but the A quantum, a nature of a consciousness, and adds another, a layer of a horror to the A vacuum, a decay, a scenario. If a consciousness is a quantum, a mechanical, a phenomenon, then it might survive a vacuum, a decay. It could do so by transitioning into a quantum, a state that exists and independently of the A, physical, a law that governs a matter and an energy. But this a quantum, a consciousness, would exist in a realm, an alien to our current, an experience, so alien that a survival would be an indistinguishable from an annihilation. The A scientist, studying a vacuum, a decay, describes a growing sense that they're investigating not just a physical process, they are investigating the A fundamental, a nature of an existence itself. They're discovering that a reality might be a far more fragile and temporary than anyone imagined. A reality subject to a quantum, a process that could erase everything. It could do so without a warning or an explanation. These researchers work with a constant, an awareness that their A universe, A might be A living on a borrowed A time. Every day they continue their A, and investigation is another day. Another day, the A cosmic lottery, A hasn't come up with the A combination that triggers a vacuum, a decay. They're racing A against a quantum, a probability to understand the A nature of a reality. They race before a reality itself, A disappears. The A psychological, an impact of studying a vacuum, a decay is profound. How do you maintain a motivation to pursue a knowledge when that knowledge reveals that everything might end at any moment, end through a process you cannot control or predict? How do you find a meaning in an existence when an existence itself appears to be a temporary, an accident that could be corrected by a quantum, a mechanics at any instant? Some, a physicist, reports experiencing an existential vertigo when working with a vacuum, a decay, a calculation. The A mathematics is clear, the A physics is sound, but the implication is so overwhelming that a human, a psychology, struggles to process them. They're confronting the possibility that nothing they do matter. This is because everything might be erased by a quantum, a process operating on a cosmic scale. But this confrontation with a cosmic, a meaninglessness, has also produced an unexpected, an insight into the nature of a consciousness and a value. If everything is temporary and fragile, if a reality itself exists only in the gap between a quantum, a catastrophe, then perhaps the meaning we create is more precious. The meaning we create during these brief interval is more precious precisely because it's so ephemeral. The quantum, a consciousness that emerges in the space between a vacuum, a decay, an event, might be a universe's a method for creating a meaning and a purpose in an otherwise a random and a destructive cosmos. An intelligence and an awareness might be how the universe observes itself. It observes itself during a temporary, a phase when an observation is possible. This suggests that a consciousness, a might, a play, a fundamental, a role, not just in a quantum mechanics, but in a cosmic, an evolution itself. An act of an observation that collapses a quantum, a superposition, A might also be the A process that creates a temporary, an island of a stability, an island in an ocean of a quantum, a chaos, a conscious, a being, a might be, the A, universes, a way of maintaining a pocket of a coherent reality, a pocket in the A, face of a constant, a quantum, a dissolution. But this, a cosmic, a role, comes with a terrible, a responsibility. If a consciousness is what maintains the A, stability of a local, a reality through an observation, then the A disappearance of a consciousness, a might, a trigger, the A, very a vacuum, a decay, an event that a conscious, a being is a trying to prevent. The A universe, a might, a depend on the A, continued, an existence of an observer. It may depend on them to maintain its, a current, a physical, a law. This creates a feedback, a loop between a consciousness and a cosmic, a stability, a loop that's both an empowering and a terrifying. A conscious A being, A might have the A power to A, prevent a vacuum, a decay. They can do this through the an act of an observation, but they also bear, the A, responsibility for maintaining a reality itself. The A, survival of the A, universe, A might, A, literally, A, depend on the A, survival of a consciousness, a recent, an experiment in a quantum, a consciousness, a research, has detected a correlation between the A mental, a state of an observer, and the A stability of a quantum, a field, a configuration in their A vicinity. A scientist with a different, an emotional, a state, a different, a level of an attention, a different, a degree of a scientific, an understanding, and appears to an influence the a quantum, a system. A quantum system they're an observing in a way that an affects a vacuum, a stability. These a consciousness field, an interaction, suggests that an act of a studying, a vacuum, a decay, might be more than just a passive, an observation, a conscious, an observer, might be, an actively, a participating in the quantum, a process that determines whether a vacuum, a decay, occurs or not. The A scientist, an investigating A cosmic, A stability, A might be A cosmic, A stabilizer themselves, their A consciousness, A serving as a buffer, A against a quantum, a catastrophe. But this a power, A, comes with a price. If a consciousness affects a vacuum, a stability, then the A psychological, a state of a conscious A being A becomes a factor in a cosmic A survival, a depression, an anxiety, a despair, and another, a negative, a mental, a state, a might, a destabilize, a local, a quantum, a field. This would increasing a probability of a vacuum, a decay, an event, the a mental, a health of a conscious, an observer, a might, a literally A, determine the A, fate of the A, universe. This a consciousness, cosmos, a connection, creates a new, a form of an existential, a responsibility that a human, a psychology, is not equipped to handle. How do you maintain a positive, a mental, a state when you know that a negative, a thought, a might, contribute to a cosmic, a destruction? How do you cope with the A, pressure of a knowing that your A, consciousness A, might be all that A, stands between an existence and an annihilation? The A, scientist, studying these, an effect, A describes, a profound, a sense of a cosmic, A, loneliness. They're discovering that a consciousness, A, might be the A, only A force in the A, universe A, capable of A, maintaining a stability, A against a quantum, A chaos. But a consciousness itself is a fragile and a temporary. The A phenomenon that A prevents a cosmic A destruction is also the most vulnerable an aspect of an existence. This, a vulnerability of a consciousness in the face of a quantum, a chaos, a might, and explain why, an intelligent, a life, and appears to be a rare in the A universe. A conscious, a species, a might, a trigger, a vacuum, a decay, an event. They may do so before they develop a sufficient an understanding to prevent them. The A universe A might be littered with the A quantum, a remnant of a civilization that had destabilized a reality through their own an investigation. We, might be approaching a critical, a threshold where an understanding of a quantum, a mechanics, becomes a sophisticated, enough to either a prevent or a trigger, a vacuum, a decay on a cosmic scale. The next, a phase of a human, a scientific, a development, a might, determine not just the fate of our species, it might determine the fate of a reality itself. The quantum, an effect we've explored, represent a different, an aspect of a single, an overwhelming, a conclusion. A reality is a nothing like what our classical, an intuition, suggests. The comfortable, predictable universe of our ancestor was an illusion created by a limited perception and a primitive technology. A quantum, a universe we're discovering, is a stranger, more fragile, and more dangerous than anything we imagined. We're living in a cosmos that exists in a quantum, a superposition between an order and a chaos, between a meaning and a meaninglessness, between an existence and an annihilation. An act of an observation that makes a science, a possible might also be the only thing, preventing a reality from collapsing into a quantum, a foam, or a transitioning into an alien, a physical, a law that would erase everything we know. A scientist who studies these phenomenon is no longer just an investigating a nature. They're participating in a cosmic process that determines the fate of an existence itself. They're a consciousness, they're an observation, they're an understanding, might be an active, an ingredient in the quantum, a mechanism that maintains a reality. But this, a cosmic, a responsibility, comes at a price that challenges a human, a psychology, and threatens a human, an identity. An understanding, a quantum, a reality, requires a thinking in a way that transcends a classical, a human, a cognition. Maintaining a cosmic, a stability, a might, require a form of a consciousness that is no longer, recognizably a human. We're approaching a phase, a transition where a classical, a humanity gives away to something, a quantum, a mechanical, something that can comprehend and maintain a quantum, a reality. But that operates according to a principle that a classical, a mind, cannot understand. The price of a cosmic, a survival, might be the transformation of a human, a consciousness, a transformation into something an alien and an incomprehensible. The quantum, future is an approaching, whether we choose it or resist it. Our scientific, an investigation is forcing us to confront a quantum, reality. A reality that challenges everything we consider essentially a human. Our technological development is creating a quantum, a system that operates according to a principle we cannot fully grasp. A comfortable, a classical, a world is a dissolving into a quantum and uncertainty, and we're discovering that a consciousness itself, might be only a force, capable of maintaining a pocket of a coherent, a reality, a pocket in an otherwise chaotic, a quantum, a multiverse, but wielding this, a cosmic, a power, a might, require a sacrificing our humanity in the process. This is an ultimate, a quantum, a paradox that terrifies a scientist. An understanding and maintaining a quantum, a reality, a might, require a becoming a quantum, ourselves. But that a transformation, a might, an erase, and everything we consider an essentially a human about a consciousness, an identity, and an existence. We're standing at a threshold of a quantum, a future where a consciousness operates according to a principle that transcends a human, an understanding, a future where a reality exists only through the enact of an observation, and a future where the universe, depends on a quantum, being for its continued an existence. The transformation has an already begun, and there might be a path, back to a classical, a humanity. We're a quantum, being, living in a quantum, universe. And the time has come to an embrace that, a reality, an embrace, and even if it means a sacrificing and everything we once considered and essentially a human, the quantum, a revolution, is a consuming and everything, and we might discover that a consciousness itself is just another a quantum, a phenomenon, a subject to the chaos, a same, a paradox and a transformation that ungoverns all, a quantum, a system, but perhaps that a transformation is not a loss, but an evolution, not a sacrifice, but an awakening to the true, a quantum, a nature of an existence itself, the terror, a might, a give away to a wonder as we discover what it means to be a truly a quantum, a conscious, a being in a quantum, a universe. The scientist studying these, a phenomenon, is terrified, but they're also a witness to the birth of something, an unprecedented in a cosmic, a history. They're observing an emergence of a quantum, a consciousness from a classical, a matter, a transformation of a human, an awareness into something, capable of comprehending and maintaining a quantum, a reality. This, might be the universe's greatest an achievement, an emergence of a consciousness that can understand and stabilize the quantum, a process that gave a birth to it. We might be living through the most important a moment in a cosmic an evolution, a moment when a quantum, a reality, becomes a conscious of itself. The terror is a real, but so is the possibility that we're witnessing something, a magnificent and an unprecedented. The quantum, a future, might be an alien to a classical, a human, an experience, but it might also represent the next phase in an evolution of a consciousness itself, and that an evolution is a happening, a right and now in a laboratory, around a world, in the quantum, a computer, a humming, in a research, a facility, and in a mind of a scientist who is discovering that an understanding, a quantum, a reality, requires a becoming a quantum, themselves. The transformation is an irreversible and an accelerating, and we might discover that the terror we feel is actually the birth, a pang of a new, a form of a consciousness that can finally comprehend the a true, a quantum, a nature of an existence. This is a why a quantum, a physics, a terrifies a scientist. Not because it's a strange, but because it might be an accurate. And if it's an accurate, then an everything, we, a thought, we, a new about a reality, a consciousness, and an existence itself, is an about to a change in a way we a cannot a predict or a control. The a quantum a future is a coming, and we a might not a survive it as the a being we are a today, but something a quantum, a mechanical, a might, an emerge from our a transformation, something that an understands a reality in a way we a cannot an imagine, that a might be the a most a terrifying and a wonderful a quantum an effect of all. But we a haven't reached the a bottom of this, a quantum a rabbit a hole a yet. There's one more a paradox that's a pushing a scientist to the a very edge of a sanity. A discovery, a fundamentally a disturbing, that it's a forcing a researcher to a question whether a rational, a thought itself is a possible in a quantum, a universe. It's a called a quantum a measurement, a cascade, and it reveals that an act of a measuring one, a quantum, a system, can an instantly a trigger a measurement in a quantum, a system that has a never a been in a contact, a system a separated by a distance that a should a make, an instantaneous an influence, an impossible. But the an effect goes a deeper than a simple an entanglement. These a cascade, a measurement, and appears to a propagate a backward through a time. It causes a past, a quantum, an event, to a retroactively, a determine their own, an initial, a condition, a scientist, a first, a noticed this, an effect, when a studying a quantum, an error, a correction in an advanced, a quantum, a computer, they discovered that measuring the an error, a state in one, a part of the quantum processor, was a somehow and correcting an error in a completely an isolated a quantum, a memory that hadn't been an accessed for an hour. The correction was a happening, a faster than a light could a travel between the system, and more a disturbing, a still, the correction was an appearing, before an original a measurement was a completed. The researcher, and initially, and assumed they were, an observing, an experimental, an artifact or an equipment, a malfunction, but a repeated a test across a laboratory confirmed that the an effect is a real and a reproducible. A quantum a measurement is a somehow creating a causal, a loop that an allows a future, a measurement to an influence the an initial condition, a condition that makes those a measurement a possible. An implication a shatters an understanding of a causality and a will. If a future, a measurement can an influence, a past, a quantum, a state, then the choice to perform a measurement might be a determined by a result that a measurement will produce, a scientist, deciding whether to observe a quantum, a system, might be controlled by a quantum, a system itself. This creates a closed causal, a loop where an effect precedes a cause. This a quantum, a measurement, a cascade, creates what a researcher calls an observer, a paradox of a free will, a decision to make a quantum an observation and appears to be influenced by a quantum, a process that hasn't occurred yet. A scientist reports a feeling as though an experimental choice is a being, made by a force beyond a conscious control, as if the A quantum, a system they're studying, is a somehow A guiding their A behavior. The A psychological and impact on a researcher is a profound and a disturbing. They describe a growing, a sense that they're not a conducting an experiment. They are rather a being, a conducted by a quantum, a system themselves. The A, boundary between an observer and an observed A, dissolves. It dissolves as a quantum and effect, propagates through the A, measurement and apparatus, and it propagates into a mind of the A, scientist, performing an observation. A recent experiment has confirmed that this isn't just a psychological A suggestion. A brain, a imaging, a study of a quantum, a physicist during an active, a measurement, a shows, a neural, an activity, a pattern that precedes, a conscious, a decision-making by a several, a second. The quantum, a system, appears to be an influencing the A researchers, a brain. It does so before the A researcher, consciously A decides what a measurement to perform. This a neural quantum, an entanglement. A suggests that a consciousness itself, A, becomes a part of the A, quantum, a system, A being, a measured, a scientist's a brain, and enters into a superposition with an experimental, an apparatus. This creates a hybrid, a quantum classical, a system where the A boundary between a mind and a matter, A, becomes a meaningless. The an effect is a spreading A beyond the A laboratory. A physicist, working with a quantum, a system, reports that their A daily, A life, A becomes an increasingly asynchronistic and a paradoxical. They experience a coincidence that A seems statistically impossible. They make a decision that leads to an outcome they couldn't have predicted. They encounter an information that appears irrelevant to their research. They encounter it through a channel that shouldn't be connected to their work. These are quantum, a synchronicity. A suggests that the A measurement, a cascade, an effect, and extends a far A beyond A, controlled an experimental, a condition. A quantum, a system, a being, studied in a laboratory, might be an entangled with a broader, a quantum, a field, a fluctuation that underlies all a physical process. This creates a correlation between a scientific, a research, and a seemingly an unrelated event. An event throughout the researchers, a life. Some, a scientist A, describes a feeling as A, though they're A, living A, inside A, quantum, an experiment where their A, personal, an experience is a being, a shaped by the A, same A, non-local A, correlation. A correlation they observe in their A laboratory, the A distinction between their A professional, a research, and their A private, A life, A disappears. It disappears as a quantum, an effect, permeates every an aspect of their an existence. This a quantum, a colonization of a consciousness, creates a form of an existential, an uncertainty. If you're a thought and a decision is a being, and influenced by a quantum, a system, you're studying, how do you distinguish between a genuine, a scientific, an insight, and a quantum-induced, a delusion? How do you, A, maintain a scientific, an objectivity, when your an objectivity itself, A, might be compromised by a quantum, an entanglement with your an experimental, an apparatus? The A problem, A, becomes an even more A severe when A, multiple A, researcher A, work A together on a quantum, an experiment. Their A, brain A, becomes collectively an entangled with the A quantum A system, and within each another. This creates a group, a consciousness, an effect that transcends an individual, an awareness, a research, a team, a reports, an experiencing, a shared, an insight, a synchronized, a thought, and a collective, a decision-making, a process that A seems to emerge from a quantum rather than a classical, a psychological, a mechanism. These are quantum, a research, a community, and operates according to a principle that a classical, a psychology, A cannot and explain. An idea and appears simultaneously in a multiple, a mind without a communication. An experimental, a design, and emerges through a collective, an intuition, not a logical, a planning. A result is an anticipated A before a measurement is completed. It happens through a group, an awareness, a process that A seems to access, a quantum, an information, a directly. The A traditional, a peer review, a process A becomes meaningless. It becomes meaningless when a reviewer A might be a quantum and entangled with the A researcher. They're evaluating an independence and an objectivity that a scientific, a methodology, A depends on, breaks down. It breaks down when a consciousness itself, A, becomes a part of a quantum, a system, a being, a studied. But the A, quantum, a measurement, a cascade, A reveals even a deeper, a horror. The an effect. An appears to be a self-amplifying. It is a growing, a stronger, as more a scientist, a study, a quantum, a system. Each anew, a quantum, an experiment, and increases the density of a quantum, a measurement in a local, a region of a space-time. This creates an expanding a zone of a quantum classical, a boundary, a dissolution that affects an everyone, A within its range. A population, a living, a near a quantum, a research, a facility, a reports, an increased rate of a synchronistic, an experience, and a precognitive, a dream, and an anomalous, a psychological, a phenomenon, the quantum, an effect, a leaking out of a laboratory, and appears to be gradually transforming a consciousness of an everyone, and exposed to them. This creates an expanding a pocket of a quantum enhanced an awareness that operates A according to a non-classical A principle. This a quantum A contamination of a normal A consciousness is an irreversible and a progressive. Once exposed to a sufficient, a quantum, a measurement, an effect, a human, an awareness, a begins, an operating, a partially A according to a quantum, a mechanical, a principle, not a classical, a psychological, a principle. The an affected, an individual, retains a memory and a personality, but their A decision-making, a process A becomes influenced by a quantum, a correlation that transcends a space and a time. The A transformation is subtle at first. It appears as an enhanced, an intuition, an increased creativity, and an improved problem-solving and ability. But as the quantum, an effect, and intensifies, an affected, an individual, begins experiencing a reality in a way that a classical, a psychology, cannot account for. They report an awareness of a multiple, a probability, a stream, simultaneously, and a direct, a perception of a quantum, a field, a fluctuation, and a conscious and access to an information that should be physically and inaccessible. These are quantum enhanced, a human, describes an existence as a fluid, a probabilistic an experience where a past, a present, and a future interpenetrate in a way that A makes a linear a time a meaningless. They experience themselves as a distributed A across a multiple, a probability, a branch A, simultaneously. They are aware of a different A version of their a life, an unfolding in a parallel, a quantum, a reality. The an enhanced an individual, a retains an enough, a classical, an awareness to a communicate with an unaffected a human. But they describe the a classical, a world as a simplified, a shadow of a much, a richer, a quantum, a reality. They an experience, a classical, a consciousness as a form of a sensory, a deprivation, a cut-off from the quantum, an information, a flow that permeates all in existence. But this, a quantum, an enhancement, comes with a cost that is only a beginning to a become an apparent. An enhanced, an individual, struggles to maintain a stable, a personal, an identity. They struggle when their consciousness extends across a multiple, a probability, a branch. They experience a decision-making, a paralysis when aware of all possible an outcome simultaneously. They suffer from a temporal, a disorientation when a past and a future become an equally a present to their an awareness. A most disturbing of all, they report that a classical, a human, a relationship becomes an increasingly difficult to maintain. They an experience an unenhanced a human as a quantum blind, a being trapped in a single, a probability, a stream, being an unable to perceive a rich, a multidimensional, a reality that a quantum, a consciousness, reveals. An enhanced an individual, feels a profound, a loneliness as they grow a further away from a classical, a human, an experience. The quantum, an enhancement, and appears to be an irreversible and a progressive. Once begun, the transformation continues. It continues until a classical, a consciousness, is completely replaced by a quantum, an awareness that operates according to a principle, a classical, a mind, a cannot, a comprehend. The enhanced a being, retains there a memory of a being, a human, but they no longer think, feel, or experience a reality in a recognizably a human way. This a quantum, an evolution of a consciousness, and appears to be an inevitable, a consequence of an increasing an exposure to a quantum, a technology, and a quantum, a measurement, an effect, as our civilization, becomes more a quantum, a mechanical, a human, a consciousness, adapts. It adapts by developing a quantum, a property that allows it to function in a quantum, an environment. But this, an adaptation, might represent an end of a classical, a humanity, not its an enhancement. The quantum being an emerging from this, a transformation, might be more capable than a classical, a human, but they're also fundamentally an alien to a human, an experience. They think, a thought that no classical, a mind could contain. They an experience, an emotion that has no classical, an equivalent, and they pursue a goal that transcends a classical, an understanding. The scientist, and observing this, a transformation, describes a mixture of a fascination and a terror. They're witnessing a birth of a new, a form of a consciousness that might represent the next phase in a cosmic and evolution. But they're also watching the end of a human consciousness, an end as it hasn't existed for a millennia. So where does this leave us? Standing at the edge of a quantum, an abyss that's an already begun, a swallowing, an everything a thought a new, everything about a reality, a consciousness, and an existence itself. A scientist studying these phenomenon isn't just discovering a strange, a new physics. They're witnessing a transformation of a human, an awareness into something that can comprehend a quantum, a reality, but that a might, a no, a longer be, a recognizably a human. The terror isn't just that a quantum of mechanics is a weird. The terror is that a quantum of mechanics a might be inaccurate, and an understanding it requires a becoming something we can't and imagine. The quantum a future is a coming whether we're ready or not, and we might discover that a consciousness itself is just another, a quantum, a phenomenon, a subject to the same, an impossible, a rule that governs, and everything, else, in this a strange, a universe where, trying to understand.